Okay, today we're going to look at the second chapter on growth model. Talk about first thing we talk about is linear growth. A recursive relationship is a formula which relates the next value in a sequence to the previous values. The quantity starts at size p sub 0 and grows by d every time period, then a quantity after n time periods can be determined using either of these relationships. A recursive formula would be p sub n is equal to p sub n minus 1 plus d. Let's call an explicit formula would be p sub n is equal to p sub 0 plus d times n. Okay, in this case, d is what's called the common difference. It's the amount it changes each time period. And n is the amount of time periods. So let's look at some examples here. Okay, the number of houses in the town has been growing according to the recursive rule p equals p sub 0 equals p, or not 0, n. P sub n equal to p sub n minus 1 plus 30. And we know that p sub 0 is equal to 200. So let's calculate p1 and p2. So p1 would be p sub n minus 1, 1 minus 1, plus 30, which is essentially p1 is equal to p0 plus 30. So p1 is equal to 200 plus 30, which is 230. P2 would then equal P1 plus 30, which is 230, plus 30, which is 260. Well, what would it be? It's find the explicit formula. The explicit formula is P sub n is equal to P sub 0 plus ND. So in this case, P sub n would equal P sub 0, which is 200, plus n we don't know, but we do know D is 30. So there's P1, P2, and there's our explicit formula. Use your formula to predict the number of houses in 10 years. So we want P sub 10, where n is equal to 10. 200 plus 30 times 10, 200 plus 300, 500. And that is C. When will the number of houses reach 400? So now we know what P sub n is. 400 equal to 200 plus 30, and this should be n, not d, times n. So first thing I need to do is subtract 200 from both sides. So I have 200 is equal to 30 times n. Then divide by 30. 200 divided by 30. 6.67 is equal to n. 6.67 years, and that is D. Okay, so let's look at some more examples. The population of elk in the national forest was measured to be 12,000 in 2003. 2003. And was increased again to be 15,000 in 2007. If the population continues to grow linearly at this rate, what will the elk what will the elk population be in 2014? So, remember your formula. P sub n is equal to P sub 0 plus n times d. Okay, the problem here is we don't have d. However, we have a P sub 0, and we have a P sub n where n equals 4. 2007 minus 3. So 15,000 equals 12,000 plus 4 times d. Subtract 12,000 from both sides, we get 3,000 is equal to 4d. Divide by 4, and we get d equals 750. Now we want to know what the population will be in 2014. So in this case, n is 11. So P of 11 is equal to P sub 0, which is 12,000, plus 11 times D. So we have 12,000 and 11 times 750 plus 8,250, and we have 20,250 bears. Are it bears or elk? And that's it. Keep in mind when doing this type of things, the trends we use to form these formulas don't necessarily continue forever. So here's an example of this. Suppose a 4-year boy is 39 inches tall. You're told to expect him to grow 2.5 inches per year. How tall will the boy be in 2 years? So P sub n is equal to P sub 0 plus nd. Now we know what P sub 0 is, 39 inches. And we know what d is, 2.5 inches. So for our first question here, P sub 2 is equal to 39 plus 2 times 2.5. 39 plus 5, 44 inches. And that's reasonable. How tall will he be in 10 years? And now let's use P sub 10 equal to 39 plus 10 times 2.5. We go to 39 plus 25, which is 64 inches. Again, that's feasible for a 14-year-old. 5'4". But how about at 50? A piece of 50 is equal to 39 plus 50 times 2.5. 39 plus 50 times 2.5 is 125. 164 inches. So 13 feet 8 inches roughly. So as you see, our formula falls apart as time passes. And the next thing we're going to talk about is exponential growth. So if a quantity starts at a size P sub 0 and grows by r%, again, we need to write our percentages as decimals every time period. Then the quantity after a time period can be determined by using either of these relations. We have a recursive form here, and we have an explicit form. R is called the growth rate. The term 1 plus R is called the growth multiplier or common ratio. So let's look at an example of this and see how this will work. In 2007 and 2008, Olympia, Washington grew almost 3% to a population of 245,000 people. this growth rate was to continue, what would be the population of Olympia in 2014? So what do I know? I know P sub 0 is 245,000. What else do I know? I know my R is 3%. As a decimal is 0.03. And I know my N, P sub 0, was for 2008, not 2007. Be careful. So N is 6. I think I have everything I need. P sub 6 is equal to 1 plus R, which is 0.03, times P sub n minus 1. Nope, can't do that. To the nth power. And n is 6. I'm missing something. Oh, P sub 0. 245,000. So P sub 6 is equal to 245,000 times 1.03 to the 6th power. Now, most calculators, you'll have a button like this. That's how you raise something to a power. So you would simply type in 1.03, hit that button, hit 6, and then hit equal or enter, whatever your calculator takes. So we have 245,000. This is 1.1941 rounded to 4 decimal places. Do try this on your calculator, see if you get something similar. And multiply it by my 245,000, and I get 292,542.8126. So we would round this up to 292,543 people. Okay, now we're going to talk about exponential and common logarithms. Common logarithm, written simply log of x, undoes the exponential 10 to the x. This means that the log of 10 to the x is x, and likewise 10 to the log x is x. Therefore, 10 to the a equal b is equivalent to saying the log of b equals a. Another thing we need to look at is an exponential property of logs. It says that if you have the log of a to the r, it's equal to r times the log of a. So let's look at some of these common logarithms and see what we're looking at here. So our first one is 10 to the x equals 100. So the log of 100 equals x. Again, you should have a log button on your calculator, which makes x equal to 2. Next thing here, the log of 3 is equal to x. This gives me x is equal to 0.4771, and we'll stop there. Okay, now this next one, I have 2 times 10 to the x equals 8. So first, divide by 2, so I get 10 to the x is equal to 4. So the log of 4 equals x, and we get x equals 0.6021, rounded to 4 places. Practice these, make sure you can do this. Portland's population in 2007, 568,000, and had been growing by a rate of, well, that's P0. R equals 1.1%, which is 0.011. Write a recursive formula for the population of Portland. So let's go back and look at our recursive. Okay, 1 plus r times p to the n minus 1. So our recursive formula, p sub n equals 1 plus r to the n minus 1. So p sub n equals 1 plus 0.1, 0.011 times p to the n minus 1. So p to the n equals 1.011 times p to the n minus 1. That's it. Okay, so now we write an explicit formula. Go back and look at this. Okay. So for b, our explicit formula is p to the n, p to the 0 times 1 plus r to the n. P to the n is equal to p to the 0, which is 568,000 times 1.011 to the n. Okay, if this trend continues, what will Portland's population be in 2016? So looking at C, going to use that formula there. 2016 will be 9 years from 2007. P sub 9 is equal to 568,000, 1.011 to the 9th. And 568,000 times 1.011 to the 9th. I get 1.1035 rounded to 4. Multiply that by my 568,000. And I get 626,770, and we round up to 1. And I guess those are people. Okay, same type of problem. We have a native wolf species introduced. Originally 200 wolves. That's p sub 0. After 3 years, so p sub 3 is equal to 270. If the population grows exponentially, what is a recursive formula for the number of wolves? Well, we don't know what r is. Remember, we're looking at recursive a p sub n equals 1 plus r times p sub n minus 1. Problem is we don't know what r is. So I would go to b. Think about b. P sub n equals p sub 0 times 1 plus r to the n. Again, we still don't know. But we have a p sub 3 and we have a p sub 0. So using this formula, we have p sub 3 equals p sub 0 times 1 plus r to the third. This is 270 plus 200, 1 plus r to the third. Divide 270 by 200. 1.35 equals 1 plus r to the third. Okay, now let's go up here. I have 3 to the third, and I take the third root of it. This and this cross out, and I get 3. So try this. 3 to the third is equal to 27. 27 to the 1/3 is going to be equal to 3. How would you key this in? Get 27. Use that caret button again. Open a parentheses. Do 1 divided by 3, and don't forget to close the parentheses. And that will give you 3. So what we're going to do here is we're going to take the 1/3 root of that. Right? And that's equal to 1 plus r. So 1.35 to the 1 divided by 3 equals 1.1052, and that's 1 plus r. Subtract it, and r equals 0.1052, or 10.52%. That's not what we're looking for. We're just looking to put that in here. So this becomes p sub n equals 1 plus 0.1052 times p sub n minus 1. This is p sub n equals p sub 0, which we had as 200, times 1 plus 0.1052 to time to the n. So our two formulas become p sub n equals 1.1052 times p sub n minus 1, or p sub n equals 200 times 1.1052 to the n. So that's A and B. C, if the trend continues, what will it be in 10 years? So now we're looking for P of 10, which is 200 times 1.1052 to the 10th power. So this becomes 200 times 2.7190, or roughly 544 volts. Okay. The third type of growth model we'll look at is logistic growth. Population is growing in a constrained environment with carrying capacity K. An absent constraint would grow exponentially with growth rate R. Then the population behavior can be described by a logarithmic growth model. P sub n equals P sub n minus 1 plus R times 1 minus P sub n minus 1 over K times P sub n. So this is one that we can only use a recursive formula for. This takes a long time. So while I believe there is a homework problem, there is not a test problem on this. So let's look at how this works. Write the recursive formula. Let's see what we have. Blackberry plants started growing in my yard, absent constraints. Spread it 200% a month, so R is equal to 200%, which is 2. My yard can sustain 50 plants, so K is equal to 50. Using logistic growth model. Okay, and we had P sub 0 is 10. The logistic growth model is P sub n, P sub n minus 1 plus R, which is 2, 1, minus P sub n minus 1 divided by K, which is 50, and P sub n minus 1. That would be our recursive formula. So let's find P of 1, or P sub 1. This would be P sub 0 plus 2 times 1 minus P sub 0 over 50, again times P sub 0. So we started out with 10 plus 2, 1 minus 10 over 50 times 10. So I have 10 plus 2, 10 over 50, so this is 0.8 times 10. This becomes 10 plus 16, which is 26 plants. So next up, we're going to find P sub 2 equal to P sub 1, which is 26, plus 2 times 1 minus P sub 1, 26, 50 times P sub 1. So 26 divided by 50 is 0.52. 26 plus 2 times 1 point, or point 0.48 times 26. 26 plus 0.96 times 26. 26 plus 24.96, which we'll call 25, which is 51. So here at P sub 2, we have 51 plants. Now, the thing was, our carrying capacity is 50. So what do you think is going to happen for P3? Well, something's going to die. So P3 is equal to P2, which is 51, plus 2 times 1 minus 51 over 50 times 51. And here you'll see what happens. We have 51 plus 2 times. This is 1 minus 1.02. So see what happens here is we end up with a negative 0.02, 51. We end up with 51 plus negative 0.04 times 51. 4 times 51. So I get 51 plus negative 2.04. This will be roughly 49 plants. So that's what happens. So we lose some to get below the carrying capacity. Okay, example 9. Suppose you have a bowl of 500 M&M candies, and each day you eat 1/4 of the candies you currently have. Is the number of candies left changing linearly or exponentially? Write an equation to model the number of candies left after n days. So, well, it's changing by 1/4, which is what? 0.25, which is what? 25%. It's not changing by a set number of M&Ms, it's changing by a percentage, which is a rate. Therefore, exponentially. Well, what is it? Let's see. P sub n equals, let me go back just to make sure. Okay, P sub 0, yeah. P sub n equals P sub 0 times 1 plus R to the n. P sub n equals, we had 500 to start with, 1 plus 0.25 to the n. Up. It's shrinking. Don't forget the negative. So this becomes 500 times 0.75 n. And that's P sub n. And that would be it. Okay, so this ends the second chapter. I hope everybody's doing all right. As I said, the first day of class, we will be, I always answer emails. If you have any questions, feel free to email. And we'll talk to you later. Have a good day.